Student, in our lecture 1, we have studied about the definition of partial differential equation, what is partial differential equation, and what is partial derivatives, and where partial derivatives are used, and why we need to derive partially about a function having one dependent variable with a function of two or more independent variable, and what is the what are other definitions that's needed for your partial differential course, such as your order of the differential equation, degree of the differential equation, then linearity of the partial differential equation, and also we have given some examples to show which type of partial differential equations are having order 1, 2, or 3, or the degree 1, 2, or 3, and how we can derive and get the degree by normalizing a partial differential equation. In today's class, I'll give you some notation we generally use in partial differential equation, and as well as there are different types of linearity occurs in partial differential equation, and what are these type of linearity that occurs in partial differential equation we are going to discuss in this lecture. First of all, let me give you some notation which will be frequently will be using in our partial differential equation, because all the time if we use this del z del x or del z del y term, sometimes it looks very cumbersome. For a longer type of differential equation, it will be very, very difficult to write all the time this kind of notation. So we simplify it notations like these notations will be used for later on when there will be it will come across with any kind of partial differential equation. For example, we will use small letters like P, Q, R, S, T. I'm giving only for the first order and second order differential equation. Small p represents del z del x, where z is the dependent variable, x is one of the independent variable. That means z is a function of x and y. Similarly, small q represents del z del y, r represents del to z del x, to second derivative of z with respect to x, s represents second derivative of z with respect to x and y, and similarly small t is equal to del to z del y 2, that means the second derivative of z with respect to y. For example, if we consider this equation, if you come across with equations like this, p square plus q square equal to 1, although it looks like an algebraic equation, actually this is not an algebraic equation. This equation is a partial differential equation where p is given by del z del x and q is given by del z del y equal to 1. Similarly, we can have something like p plus q equal to r. So what will be p? P is del z del x plus q equal to del z del y and equal to del to z del x2. So this kind of equation you will always come across. In case of there are n independent variables x1, x2 and up to xn. So we can use the small p1, p2, p3 and pn. There will be no q, r, s, t and so on, but small p1 will be del z del x1, p2 will be del z del x2 and so on. Sometimes also you will use suffixes to represent partial derivatives. Like if you are having a dependent variable u, then u suffixes will represent del u del x, x will represent del to u del x2, uy will represent del u del y. Similarly, uxy will represent del to u del x del y, second derivative of u with respect to x and y. So these are the notations you are going to use, or you will come across in all type of partial differential equations when we go along with your courses. Okay. Now coming to the classification of first order differential equation, now we are going to define first order differential equation in terms of their linearity. Which type of differential equations are called linear equation and which are non-linear equation, and whether there are different kinds of linearity. In case of ordinary differential equation, you know that there is only one type of linearity, but in case of partial differential equation, you will be able to come across with three different types of linearity occurs in partial differential equation, and I'm going to define all these three. So linearity of first order partial differential equation can be divided into four forms, actually not four forms, three forms, but the last one is a non-linear equation. So first equation is known as linear equation, just simply linear. So if we have a first order partial difference, why it is called first order? Because this equation will have only first order derivative term. F, x, y, z, p, q, this is a function left hand side equal to 0. So this is an equation of first order partial differential equation where x and y are independent variable, z is the dependent variable, P represent del Z del X, Q represent del Z del Y, is known as linear if it is linear in P, Q, and Z. So in the equation, the degree of P, degree of Q, and degree of Z has to be equal to 1. That means P has to be equal to 1, Q has to be degree 1, like this, and like this. This is power of P, Q, and Z has to be equal to 1. Okay. And this is in the form like this. Capital Pxy. Now this capital Pxy is nothing but is a function of x and y. Any function of x and y. Degree may be degree of xy, may be anything, maybe more than 2, more than 1, doesn't matter. Small p has got degree 1. Qxy is a function of xy, and q has capital Qxy is a function of xy again. Small q is del z del x having degree 1. Rxy is a function of xy. Z is having degree 1. And we have another function we are representing here. Sometimes it may be constant, sometimes it may be non-zero also. So this type of equation is known as first order linear equation. For example, if we can show you this equation, say this is your capital P xy, a function of xy, small p, degree 1, xy square, this is capital Q xy, small q has got degree 1, again z has got degree 1. So this kind of equations are known as your linear equation, where P is del Z del X and Q is del Z del Y. Okay. Now, coming to the second category of your differential equation. Second category of differential equation is partial differential equation. Linear partial differential equation of first order is given by this type of equation. It is known as semilinear. This is known as semilinear differential equation. Semilinear differential equation is nothing but a first order partial differential equation is given by this one. It is known as semilinear if it is linear in P and Q. Now you see there is no restriction in Z. So degree of Z can be anything, but P and Q degree has to be equal to 1. Okay. And coefficient of P and Q. What are the coefficients? These coefficients are these functions of P, X and Y, subset of X and Y. Capital P and capital Q and capital R. These are the capital P and Q are the coefficient of small p and small q. So those coefficients of P and Q are only function of xy only. So there is no z here. So this is actually left hand side of linear equation and semilinear equations are exactly same. Okay. But the right hand side, if you see Rxy, earlier we had a Rxy, a function of xy multiplied by z with a degree 1. But here it can be having any function of xy and z. And Z may have, Z has got no restriction on the degree. Z can be having any degree. If it is any degree, it can take any degree here. Okay, this Z. So for example, if we can see this example XYP, say this is your capital PXY and it's degree 1, Q has got degree 1. But Z, if you see, Z has got degree 2. Similarly, in this equation, if you see, Z has got degree 2 and this is a function of XYZ together. Here degree 1, degree 1. So these are this kind of equations are known as your semilinear equation. Why it is semilinear? Because P and Q are having linear. P and Q are having linearity in their term degree 1, but the Z can have degree 2 also because Z is a independent variable. So even if Z is a dependent variable, it can have degree more than 1. So those type of equations are known as semilinear equation. Now the third kind of equation, if we go, the third kind of equation is known as quasi-linear equation. Now in your when you go along with our study period, you will see that there are a lot of equations which comes under quasi-linear equation. So this is neither linear, not semilinear, but it is called quasi-linear. And what is quasi-linear? Definition of quasi-linear equation. Again, if it is a first order differential equation of this kind, it is known as quasi-linear if it is linear in P and Q. So degree of P and Q are 1 and 1. But the coefficient of small p, coefficient of small q, and the right hand side Rxyz, all can be functions of z, and z has no restriction on the degree. So z can have any degree, but p and q should have degree 1. So for this example, this degree 1, there is no z here. They can put it as z to the power 0. Okay, doesn't matter. Here p has got degree 1. Q has got degree 1 and CZ has got degree 2 here. So in this case, we can say that these type of equations are called quasi-linear equation. Okay. And the last one equation is known as your last type of last form of linearity of first order partial differential equation is the nonlinear equation. That means P and Q will have degree with higher type of higher order higher degree. That P can have more than 2, Q can have more than 2 and equal to 1. And this equation will not fall under 1 or 2 or 3 category. So this is called your nonlinear equation. So we can have nonlinear equation later on. We can, when we see that the second order differential equation or any other differential equation of higher order, then we will come across with this kind of equation. So this is all for this lecture, and in the next lecture we will be starting with how to formulate partial differential equation, first order partial differential equation initially, and then we will move to the second order differential equation. Thank you.